This is the selpHbalance total dissolved solids and conductivity meter. It's a pretty nifty tool. So never been used before. So just showing you how it works, showing you that it is effective and works like it says. I went ahead and brought up here a total dissolved solids chart. We're going to be showing you the total dissolved solids first. And this is a chart showing you from the EPA basically what we should be looking at here. And these are the numbers, parts per million, that we'll be seeing. So 0 to 50 is the acceptable limits from the EPA for how much solids, parts per million, should be in your drinking water. So following our directions, we have a protective cap here that we remove. And you always want to just be protective here of your tips. You know, you do have a little bit of plastic here, and you don't want to drop this anywhere. You don't want to drop this completely in solution. Just try to be protective. After you're done using it, you want to, try to dab out some of the water and let it dry before you put the cap back on to store. Okay, so first thing we're gonna do is going to turn it on. We're already right now on the total dissolve settings. You can tell by the ppm reading. That's the measurement right there. It's also giving us a temperature as well. That's real neat. That's not normal, and I do like seeing that. That's nice. So we can hit the shift button here, and we can change to right here for EC. That's measuring the amount of salt, the conductivity, and we can push the shift button again, and we're back to ppm. But now we are in Celsius. So shift again, conductivity, Celsius, push it again. Now we're back to total dissolved solids, Fahrenheit. So when you're measuring it, the hold button here, you can see it. You get your reading and you can push hold, and it will hold the reading for you and won't go away when you pull it out. Just in case for some reason you're trying to reach down in a barrel or something you're just trying to measure. Maybe you have a well and if you're doing your measurement, then once you believe you got it, you can hit hold, pull it out. Now you can tell what you had. So that's always a very nifty tool to have on. So now we're just going to go ahead and we're going to do it. Here we have, and let me get my chart up. And I just got this chart from TDSmeter.com. It's an EPA chart. This is Asheville City, Asheville, North Carolina. Acceptable ppm rating is 0 to 50. And what's good is you don't want to submerge too far, and the slightly agitation motion's pretty good just to make sure you get a consistent reading. And looks like the reading here is 30 parts per million dissolved solid. Now, ideally, perfectly clean water is going to be very close to 0. So this right here, Asheville is highly chlorinated and fluoridated. There's just a lot of chemicals because there's a lot of water getting reused here, so they have to use extra chemicals. So alright, so let's go ahead and test the Murky Water. This is a charcoal filter using gravity feed, and this is the Asheville City water being used. So we'll see how effective the Murky meter is. Well, look at that. Murky is pretty expensive, and it's only knocked that down three parts per million. So we perhaps we may want to reconsider it, because it's probably all it's doing is managing to hide the smell and taste of the chemicals. So might want to reconsider that. See, this is a great example of this tool and how it can be used. See, in this city, it's extremely chlorinated. It's not like that in all cities. If you wanted to test that your filter is working for you, this is how you do it. You can use this meter to test. This is a great example of why this tool is essential. All right, so we're going to go ahead and test spring water, which is from the next town over. It's about 40 minutes away, and this is natural spring water. And if you look at that, remember how I said 0 is ideal for clean water? This is 2 parts per million. This has got no filter. This is nothing, coming straight out of the ground in Marshall, North Carolina. It's mountain spring water, 2 parts per million. So this right here is, again, another great example. We have extremely high dissolved solids in the city water, and this spring water is showing us just how important it is to make sure you got a clean water source. So, and again, it's 0 to 50. 50 is the maximum rating that the EPA allows, and that's not meaning that it's safe. It's meaning that it's the most they will accept to pass. So clean water is going to be as close as you can get to 0, and you know, a 30 here, it's not ideal. Not trying to say it's unsafe, but if you can get something better, choose the better option. A really great example of why this works for us is that we have fish. So we know we can't use, fish are extremely sensitive to dissolved solids. And we can't use this water for the fish. Even after we dechlorinate it, that just tells us it's not a good fish water source. So using the spring water, we'll have a great source as well. So this tool is very essential for many different industries. Here is Deer Park water, 100% natural spring water. Okay, so we just want to show you comparison how that is. So we got a 0 reading right here. I start. If you look at that, the Marshall, North Carolina was 2 parts per million. This is 3 parts per million. So this right here is telling you that Deer Park is using, oh, turned off on us, has an automatic turn off feature. That's nice. Deer Park uses a true natural spring water, and this does not have a lot of additives in it. So this right here is a great tool to tell you if your spring water has additives. All right, let's test Fiji water. This really expensive, highly sought after artesian well water.
Oh my gosh.
So let's that's reading 121 parts per million. That is not even acceptable by the EPA. So I just use this on the rag. Okay, so let's just double check. Okay, I'm gonna damp it. I don't want to touch the prongs with it. All right, let's just try it again. All right, so we're still reading in the 36 range. 35. Okay. Let's go back to Fiji. 134, 35, 136 parts per million dissolved solids. So again, let's look at this chart again. 0 to 50 is acceptable for drinking. Carbon filtration can yield sometimes 50 to 100. Very hard water is going to be up here close to 200. Okay? This right here, Fiji, this expensive artesian water has very high parts per million. So it makes you wonder what is in this water. It doesn't seem very clean. Alright, so we will go ahead and test this final water here. This is smart water. And we are at 21 parts per million. 20 parts per million, 19 parts per million, 20, 19. Alright, so there you go. So this shows you how essential this tool is. If you can't get access to spring water from the source, this will help you discover which brand is actually going to be a safe choice for you. This is an essential tool right here, and it is definitely working very effectively. I highly recommend you get one. Okay, so now I just got done showing you the total dissolved solids. Now we're going to use the conductivity portion. Or now we're going to use the conductivity side of the meter. So we're going to turn it on. And now we're in the total dissolves Fahrenheit. And we're going to switch to conductivity, the EC. Siemens per centimeters. So this measures basically the level of salt in a solution, or the level of metal. So basically this is measuring generally your metal salt content of water or other types of water-based solutions. So the average acceptable level of conductivity for drinking water is about 5.5. So here we're measuring 63 in Asheville City water. So we got a high metallic salt content. Okay, let's go ahead and measure the charcoal filter water. 56. Measuring the spring water from North Carolina mountains, measuring a 4. Okay, so we're below the average acceptable of 5.5. This is the Deer Park water, measuring a 6, slightly above. Fiji water, 263. So we definitely have quite a bit of not only dissolved solids, but we have a pretty high content of salt metals. Okay, let's test our smart water now. .44. So this is a really good tool, and it's going to helps us see here exactly what is in our water.